Hello and welcome back. So we just came off of finding IROC, which is the instantaneous rate of change, also known as the slope of the tangent line to a function at a single point. So what we're going to do here in these examples is we're going to find the entire equation of the tangent line, not just its slope. So please make sure you're writing down these examples with the directions and everything. I'm going to get started right away. Here our example is to find the equation of the line tangent to the curve f of x equals 2x squared at the point 1, 2. So the wording is a little bit different maybe than you would say it out loud, but that's why it's important to write it down so you're not confused about what the question is asking. Okay, so find the equation of the line that's tangent to the curve. So find the equation of the tangent line. As soon as you see that in any problem, what you need to write down is the equation of a line. So remember, the most popular one that we're going to be using is point slope form, which is y minus y1 equals m times x minus x1. That's going to end up being the answer to our problem. So this is going to be our answer. We just have to fill in the important information. So the important information is going to be a point and the slope. No surprise there because it's called point slope form, right? So we want to fill in this formula with two important pieces of information, a point and the slope. So here we have a point. No surprise there. Our point is 1, 2. Great. So now we need to find the slope. That's m, of course. But what is slope here? Well, it's going to be IROC, the instantaneous rate of change. Because we're talking about a function, 2x squared, it's not linear, we have to use instantaneous rate of change. So use the IROC formula to find the slope. This example looks very similar to one that we've done already, so if you want to, go ahead and pause, try it on your own, and then check with me to see if you got the right answer. I'm going to still show the work here, but maybe I'll do it a little bit faster because it looks just like an example we did earlier with just x squared. This time it has a 2 in front. Okay, so IROC, our instantaneous rate of change formula is f of a plus h minus f of a all over h as h goes to 0. So a this time is the x value of our point. So that's important. We have a whole point this time. In the previous problems, I think we just had an x value. So here we have an x and a y. A is going to be, of course, our x value, our starting x value. So a is 1 in this problem. Let's go ahead and plug that in. So we have f of 1 plus h minus f of 1 all over h. Now we need to simplify this a little bit. So f of x is 2x squared. We need to figure out what f of 1 plus h is. What we'll need to do is we'll replace x in our formula, or in our equation, with a 1 plus h. Make sure you're doing that in parentheses. So f of 1 plus h is really 2 times 1 plus h squared. You will need to simplify this, so I'll go ahead and do this right now. So to simplify this, you'll want to keep the 2, and then you'll have to FOIL out 1 plus h squared. So I'm rewriting it like this. 1 plus h squared is 1 plus h times 1 plus h. Go ahead and FOIL that out, but keep the 2 there. So 1 plus h times 1 plus h. When I FOIL that, I'll get 1 plus 2h plus h squared. So I'm not showing my foiling. I trust that you can do that yourself. And then you will want to distribute that 2. It's going to be a 2 plus 4h plus 2h squared. So that's f of 1 plus h. When I plug back into my formula, it'll be a 2 plus 4h plus 2h squared. The other part we have to find is f of 1. So f of 1 is just going to be 2 times 1 squared, which is 2. So let's go back to our formula. This is like our scratch work. Sometimes I'll do like a dotted line here, by the way, just to separate that and say, hey, this is like my scratch work, but on the left is really like my nice formula leading to the answer work. Okay, so f of 1 plus h was 2 plus 4h plus 2h squared, so let's go ahead and write that. Minus f of 1 was 2. And then on the bottom we have an h. So our goal is to plug into the formula and simplify so that an h cancels on the top and on the bottom. So that should happen relatively quickly now. we can see that when we combine like terms on the top, we have 2's that will cancel out. So we'll have a 4h plus 2h squared over h left. We can factor out an h on the top, leaving us with a 4 plus 2h in parentheses. And now we can cancel out an h on the top and on the bottom. That leaves us with a 4 plus 2h. And then our last step, once that h has canceled out, we want to replace h with a 0. So we can do that. 4 plus 2 times 0 is just going to be 4. So that's going to be our IROC. It's not our final answer. Remember, our final answer is an equation of a line, but this is our slope. So actually, this is our m, right? That's the m, the slope that we're looking for. So I'm going to go up here and say our IROC was 4. That's what it was. So pause if you need to write down any of these steps again, but hopefully that went pretty well. So we're going to finish off this problem. We want the equation of a line, which is y minus y1 equals m times x minus x1. We're going to use the point, 1, 2, and now a slope that we just found, which was 4. So go ahead and plug in this information. y1 is 2, m, the slope that we just found, is 4, x1 is the x value of the point, which is 1. So you will want to simplify this and get y by itself. So let's go ahead and do that. You distribute the 4, it's 4x minus 4, and then add 2 to both sides. So we get y equals 4x minus 2. So that's going to be the entire equation of the tangent line. If you were to graph 2x squared, maybe I'll do it. I love graphing. So, and it's not too bad because we also know what 2x squared looks like. It's a parabola, it's just been stretched a little bit. So 2x squared maybe looks like that. So that's 2x squared. If I look at the point 1, 2, let's say that's right here, the point 1, 2, then I could draw a tangent line there. There's a tangent line. And we found the entire equation of that tangent line. This tangent line has an equation of 4x minus 2. So now I know what the whole equation of that line is, not just its slope. So a good question might be, why do we care? Well, a big theme actually in Calc 2, for anybody interested in taking that class, is really approximating harder functions with easier functions. And a line is pretty much as easy as it gets. It's the simplest type of function that we know. So what we're doing in these problems is we're using a line, which is a very simple function, to imitate a more complicated function. So if you look at the drawing that I just did, this line is very close to the graph of 2x squared. Of course, eventually it gets farther away from it, but if I'm just looking nearby, so if I'm just looking kind of close to where x is 1, close to that point of tangency, the line is very, very close to the graph of 2x squared. You would almost say it looks like it's almost the same graph, as long as you're just looking in that one area. So what the line is doing is it's almost trying to imitate or copy that graph, at least when it's close to where x is 1. So what's going to happen is you could actually use this line, y equals 4x minus 2, to imitate 2x squared. They should have similar y values as long as you stay close to that point of tangency, which is 1. So if that was a bunch of mumbo jumbo, let me explain it a little bit more. So this should have similar y values as the function that we started with, which is 2x squared, as long as we're only plugging in numbers around 1. So let me maybe plug in 1.5. How about that? So if I plug 1.5 into this line that we just found, which is going to be easier, it's something I can do without a calculator. I can plug in 4 times 1.5. It's going to be 6, but I'm getting a little bit ahead of myself. So 4 times 1.5, is 6 minus 2 is 4. That should have about the same value as if you were to plug 1.5 into your original function. This is something harder to do without a calculator, and that's kind of the point, is I'm trying to imitate something that's more challenging with a line, which is not challenging to compute, especially without a calculator. But let's figure out what this is. 1.5 squared times 2 is 4.5. So we're saying, oh, well, this line is doing a decent job of imitating this more complicated function of 2x squared, as long as you stay close to 1. If I plug in numbers further away from 1, then it won't be doing a very good job of imitating it. But here it's doing okay. The line said that we should get a y value of 4. It really has a y value of 4.5, but those are kind of close. So that's the point of finding the equation of the tangent line. Let's do one more example. This time it's a little bit tougher. So if you want, pause and try on your own, but it is going to be a little bit harder because of the function 1 over x. But let's not get discouraged. These problems are all the same. Find the equation of the tangent line, which in order to do that, we know right away that we should write down the formula for a line, which is point slope form, y minus y1 equals m times x minus x1. If you want to use y equals mx plus b, you can do that too. And the two pieces of information that we're going to need are a point and the slope. So we should know by now that the slope is going to be our IROC, our instantaneous rate of change, so we're going to have to go through a lot of trouble to find that. But our point is usually given to us. Here it's actually not. We were given an x value, but we will need an entire point. So the x value of our point is 2. But what's the y value? How can I find that? Well, you can go ahead and plug 2 into your function, right? So h of 2 is going to be 1 over 2, and that's going to be our y value. So we have a full point now. It's 2 1/2. We had to do a little bit more work to actually find the y value of the point, but no big deal. We got it. I'm ready to start our IROC process, instantaneous rate of change. So our function is 1 over x. It's actually called h this time, so I'm going to use h instead of f. Our IROC formula is h of a plus little h minus h of a all over little h as h goes to 0. So I want to find out, well, first we can plug in little a. So little a, of course, is the x value that they give you. In this case, it was 2. So I'm replacing all my a's with 2. And now we want to go off to the side and figure out what big H of 2 plus h is and big H of 2. So big H of x is 1 over x. When we plug in 2 plus h, we'll get 1 over 2 plus h. There is no way for us to really simplify that, so that's going to be what that is. Next up, we want big H of 2. So we kind of already did that when we found the point earlier. We plugged 2 in, and when we plug 2 in for x, we get 1 over 2. And that's all we need. So let's go back to our formula, our neat work, and replace big H of 2 plus h with a 1 over 2 plus h. Minus h of 2 is 1/2. So we have that. And this is all over h. Okay, so this is going to be a little bit harder for us to simplify and cancel out h's, and that's why we're looking at this example. One thing that you'll always want to do here, and something that you'll notice that stands out, is we have a fraction within a fraction, so we're subtracting fractions in the numerator of a fraction. We don't really like that. We're going to want one fraction. So what we'll want to do is we'll want to combine these two on the top, and then flip, keep, change, flip, I always say, or keep, flip, change, KFC, that's how I remember it, to get rid of two fractions and turn them into one. So the first thing we'll want to do to combine these is get a common denominator. So they don't have anything in common at the moment. They'll have to basically just trade denominators. So the second fraction will need to copy the first one's denominator. The first fraction will need to copy the second fraction's denominator. So you should be multiplying the first fraction by 2 on the top and on the bottom, and the second fraction by 2 plus h on the top and on the bottom. So that'll give us a 2 over 2 times 2 plus h. Again, I'm not going to actually distribute that 2 on the bottom, not just yet, at least. Our second fraction will have a 2 plus h on the top, and then on the bottom, a 2 times 2 plus h. Okay, so what we can do now is we can combine the two fractions on the top because they have the same denominator. Please make sure that you treat this like it's in parentheses here, because when we combine these, we'll want to distribute that minus sign. So maybe I'm getting a little bit ahead of myself, but it's not a bad idea to look ahead. So I'm combining these into one fraction. I'll have a 2 minus 2 plus h. So make sure you have parentheses around that 2 plus h that was on the top. This is all over a common denominator of 2 times 2 plus h, and then that's all over that h that's on the bottom. So we combined these two fractions into one fraction on the top. So we'll want to simplify that one fraction a little bit. So I'm moving down. We will distribute this minus sign. So that's a 2 minus 2 minus h on the top. And then combine like terms. So we see that 2 minus 2 cancel out. We still have a minus h up there. And what I'm going to do just to save some space is we'll now have one fraction divided by another fraction. So it might be hard to see, but h is an h over 1. You can make anything into a fraction. So I'm going to KFC, which is keep, flip, change. That's how we divide fractions. So we keep the top fraction the same. So the top fraction is a negative h over 2 times 2 plus h. The bottom fraction was an h over 1, so I'm going to flip that into a 1 over h. And then we change this to a multiplication problem. So it's no longer a division, it's multiplication. So what do we see happen here? Oh my gosh, I can't believe it happened. H's cancel on the top and on the bottom. Keep in mind you do still have that negative on the top. It's just the h's that cancel. And that's what we need to happen. Remember, that's step 2. H needs to cancel out. So what we have left now is a negative 1 on the top, and on the bottom we have a 2 times 2 plus h. Our last step is to replace all of our h's with zeros. So you want to go ahead and do that, replace your h with a 0, and that should end up simplifying to be a negative 1 over 2 times 2, which is 4. So we end up getting an IROC of negative 1/4, which represents our slope m in this problem. Because you don't want to forget, I know that was a lot of work, but our goal is to find the equation of the tangent line. So this was just the slope. We will have a little bit more work left to do of finding our final answer. So I'm going to actually move up here since I've run out of room a little bit, and I'm going to finish the problem by plugging in all the information we know here. So we just found our slope. It was negative 1/4. We found our point a little bit earlier, 2 1/2. So go ahead and plug in all that information. So y minus y1 is 1/2. M is negative 1/4. X minus x1 is 2. So we plugged in 3 important pieces of information. And now you do want to simplify this. So go ahead and distribute that negative 1/4. You'll get negative 1/4 x plus 1/2. And then you can add 1/2 to both sides to get y by itself. And you should end up with y equals negative 1/4 x plus 1. Whew. So quite a bit of work, but as always, the more you practice it, the easier it'll get. Please just remember those steps of finding IROC, substitute into the formula, simplify so that h cancels out, and then replace h with a 0, and then that'll get you the number that you're looking for, that slope. So we're going to take a break here, and then we're going to come back and finish this section by looking at AROC and IROC on graphs. So stay tuned, I'll see you then.